All right. So, for starters, let's talk about the final exam, and then I want to talk about JSON and API calls and things like that, kind of wrapping everything up. So I'll have the exam up. Let's see, we'll be up by 8 a.m. on Monday. So it'll be on Blackboard, like the midterm was. I'll have it up by 8 a.m. on Monday. I'm going to design it to take about an hour. I'll give you 2 or more hours to take it. It shouldn't be a time issue. What I'm going to do is, I mean, I do need to see some coding competence. So I'm probably going to make a majority of the exam multiple choice and then have 2 or 3 questions that are some coding. So most of the time would be spent, well, not most of the time, probably half the time will be spent on the coding questions. The other half would be on the multiple choice. The coding questions will probably be worth a little bit higher well, the coding questions themselves together are probably going to be worth about half the exam grade. The other half would be the multiple choice, whatever. So it shouldn't be a time constraint. Um, I'll try to take that into consideration with the coding questions, but I do need to see whether you've gotten some competence in coding. I will try to offset some of that with multiple choice questions that maybe show you code and say, what does this do? We have some choices. What line is missing? That kind of stuff. Things for they are a little bit paint by number, but in any case, um, I'll have it up by 8 a.m. on Monday. You can take it anytime during the week up until 11:59 p.m. on Friday because I'm grading it over the weekend because I have to have grades in by Tuesday. Um, so, in any case, you can decide when it best fits into your schedule based on the rest of your final exam schedule, but make sure you do take it. Uh, we had several people we had a couple of people who did not take the midterm. So they're going to be very reliant on doing well on this final exam. Remember that my policy is if you do better on the final exam than you did on the midterm, I'll replace your midterm exam grade with whatever you earned on the final. So if you bomb the midterm, you could fix that by not bombing the final. The final will be cumulative in that everything from coding one and coding two is fair game, but that is effectively saying you need to know how to make variables, you need to know how to do loops, you need to know how to write functions, work with strings. I probably will make the exam language agnostic, so you can pick whatever with the coding questions, whatever languages whatever language you want to answer with. I will probably give you code examples in either Java or C Sharp, which is basically the same thing, since that's what we've been working with all along. Realistically speaking, if I give you a code example of something from Unity as an example, it'll be in C Sharp. Um, Otherwise, it'll probably still be in C Sharp, but it's possible it'll be Java. I might use a capital S for string or something like that. But in any case, um, so definitely go back and make sure you understand the fundamentals of programming. I won't ask questions on this exam, what are the 3 ways computer programming languages mimic the way human beings solve problems? The asking questions, memory, repetition. These are things from coding one, things that built our foundation. Not really something that I'm going to test on now. At that point, that stuff should be in your rear view mirror. I'm more interested in, do you know how to weaponize a variable, an if statement, a loop, classes, functions, things like that. I tend to like coding questions dealing with string manipulation or working with an array, things like reversing every element of an array, finding the average value of all the elements in the array, that kind of stuff. Things that make you go through collections of things and do something with it. Those tend to make for good kind of exam questions. They're complex enough to show me that you know how to solve a problem, yet they're simple enough that you can get them done in a reasonably short period of time. So look for those types of questions. Go ahead. Uh, let's go with yes. I mean, all the things we've done for homework assignments, obviously. If you ChatGPT is a really good example of something. Let's say you're confused on um, working with strings in Java. You can ask ChatGPT to do something like, give me a code example of reversing a string in Java, and it'll spit out some code. You can look at it, see how it works. Go into online GDB, paste it in, make sure it runs, and then make sure you understand how it runs. I would say that's probably your most reliable example of just getting quick code examples based on the little thing you want to learn at any point in time or be reinforced. Um, but yeah, I mean, I guess that's the best answer I got for you. Um, let's see. Anything else I want to say about the exam in general? Is closed book, closed note, closed neighbor. At the end of the day, if I ask a question and it's using some word you don't recognize, I don't really care if you go and look up the word. Um, it, it's your grade. I mean, you're only hurting yourself if you don't do this stuff. I don't, it takes me the same amount of time to put in an A and put in an F, so it doesn't really matter to me. But don't cheat on it so you get legitimate feedback as to um, how you're progressing through your coding education stuff. Um, what questions do you have for me about the exam or any concepts you want me to review? Go ahead.
Well, a lot of the questions be directly related to like the projects we've been doing here, so the connect forward.
No. Yeah, I would say it's unlikely that I would reference something like I think this is what you're asking. Would I ask a question about something we've done in class, expecting that you've memorized that part of the code, this function we wrote, like remember the function we wrote, blah, 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 that does this? I wouldn't do that. It's possible if I give you a code example, I might use something that we've done that's familiar of like a player class or something like that, but it wouldn't be reliant on things so you don't have to go and memorize our projects we've done. Instead, you should just make sure you're comfortable with the things that we use to build those things up. If we view the project as building a house, you should be familiar with the hammer and the wood and all the things that had to go into building that and be able to apply it to different problems. What other questions? Go ahead. No, no. I mean, I'm going to design the exam. For those of you that are online, the question was, will it require Unity? I'm going to design the exam with the expectation that you're not going to be typing it in to something to run it. So I won't. I'm realistically speaking, I'm going to be expecting that you're going to be missing a semicolon here and there and that kind of stuff. I'm not nitpicking that. I think I had mentioned it before the midterm. It's pretty easy to tell whether somebody pretty much knows what they're doing or really doesn't know what they're doing. There's a wide gap between those two people. So I'm not really that interested in a missing semicolon here and there unless you know, have shown the habit of semicolons don't exist in the in the language or something like that, or you've never seen a curly brace before. Um, but I'm looking for more of the logic piece of it. Yeah. It sounds it might actually I think it isn't it 60/40. Just the exams are weighted the same. So I mean, so it's 40% is your class, so it'd be 20% each, I get this, but 40% is your entire exam average. Um, but the two average together. So if you got a 0 on the midterm and you come in and get a 90 on this, then you got 90 for 40% of your grade. What else? If I remember correctly, I think the midterm went better for at least from a time problem. If I remember, I don't remember, was it the midterm or the final? One of the tests last year or last semester was took too much time. I mean, I still got enjoyment out of your suffering, but I also want to make sure that I'm accurately measuring what you've learned and not just it being a torture fest. All right. Anything else for me before we jump into some JSON stuff? If I were you, I'd set aside at least a couple hours for the exam just to be safe. Um, uh, but like I said, it'll be up by 8 a.m. on Monday. Whenever you sit down to do it, you got to finish the whole thing in that period of time. But just take it sometime before midnight on 11:59 p.m. on Friday. So I have the weekend knowing they're all complete. Yeah.
So the slides would be just like review in advance for it, or
Yeah. I mean, I would go through the slides, but the slides are going to kind of push you in the direction of, the things we introduced in class. I would think that a better way of going through it might be just kind of going back through the homework assignments and just focusing less on what did the homework assignment do. You've heard me reference before that, I try to treat it like you're hiding the dog's medicine in its food. So don't think about the actual thing we made. Think about the things we had to use to make it. Those are the things that are important that I wanted you to pick up on. Okay, so let's hide this here. If you want, you can get the lights or whatever if you're interested. All right, so this is all going to kind of come together in this last piece. This is probably something I wanted us to have some more time working with, but it's not that important. You have all the skills to do with it. You'll see how easy it is, relatively speaking. So for starters, how many of you have heard of something called an API? All right, what's an API?
process to server itself.
Okay, those are all true statements. So you send requests to an API. Go ahead.
Have like already built code that works like a back end so that you can have I don't know, like a calculator API that rather than you having to make all of that and whatnot, you can just give it the input and get the output out.
Okay. So it's effectively there's a program that lives somewhere that is sitting there listening for people to make requests to it. And each API has the things it knows how to do. Okay, so for instance, if I were a knock knock joke API, which maybe that's a bad example. I don't know if I know many knock knock jokes, but we'll stay abstract. If I'm a knock knock joke API, you might make a request to me for tell me a knock knock joke. I would then respond with a random knock knock joke. And then you could take that. So you would make the request from your computer program that you're writing to the source of knock knock jokes. Say, give me a knock knock joke. It sends you the knock knock joke back. You receive it inside the program and you do something with it. All right, makes some sense. That's what an API is generically. Application programming interface. Sometimes people will refer to as an abstract programming interface, but effectively, it's a data source that you can call. You can run it on your own computer if you want to write your own APIs and then talk directly to it on your own computer, which is actually something that's common. Or there's lots and lots and lots of APIs that are already out there. Weather Channel has an API. You can find out what the hourly forecast is if you wanted to write an app around that. Here's just an example for today. I am working with this API that gives us cat facts. All right. I wrote this in Python here. A little bit of a cheat code so we can get through this quicker. Java and C# both can work with JSON, no problem. We're going to be talking about JSON here, but they require it's like third-party libraries that are very difficult to get into. Basically, you'd have to unpack it and throw the Java files or the C# files up to online GDB in order for it to do it. Python effectively speaks JSON, so it just works. Okay, so this allows us to keep it as simple as possible. Again, programming's the skill set, the language doesn't matter. So at this point, you've had a year of programming. You should be able to read code in basically any language and see the overlap. All right. So in any case, here's this guy right here is a function called define cat fact. So somebody wrote this. So, well, I mean, I copied it out of something. So here's this function, get cat fact, takes no inputs. What it does is it visits a website. So that's the website it's going to go to. That's the endpoint on the internet. So catfact.ninja/fact. Give me one of those. And what we can do here is if we just visit that directly, I'm going to just copy that. This is the kind of thing it gives me here. So I just go to that site, and when you make a request to something from a web browser, the type of request it's making is something called a GET request. Just to throw this out there real quick. APIs use the HTTP protocol for communication. These guys are usually called RESTful APIs. So RESTful or REST APIs. How many of you have heard of that phrase before? Something being a REST API. These would fall into the category of things that sound complicated but are really boring things. So our modern day popular API types are all REST APIs. Leading up to that, APIs followed a less standardized approach. You might have somebody who, if I wrote an API, I would have to tell you the protocol that you would have to use to request stuff from my API. Somebody else wrote one, they would also have to teach you the right way to talk to their specific API. When something follows a standard like REST APIs follow, you always can talk to it using the HTTP protocol. And then they just have different endpoints, things they know how to do. Give me a knock-knock joke might be one thing. Give me the hourly weather given my latitude and longitude, that kind of stuff. Okay, so an API might have 500 different endpoints, 500 different things it can do. But those things will be spread across 4 different function types, which is the entire HTTP protocol. So let me spell that out a little bit here. So HTTP, this is hypertext transport protocol. In technology, whenever you see the word protocol, it means language. This is we're speaking the English protocol right now. All right, so we would use the HTTP protocol. What's the HTTP protocol? The language that web browsers speak to web servers. That's what that language is, HTTP. Now, when somebody says internet, the first thing we probably think of is web browsers, right? In the early days of the internet, web was just one of the pieces. We also had FTP, we had Telnet, there used to be a service called Gopher. It's been kind of replaced with search engines and stuff like that. But in any case, one of our earliest realities of the internet was this idea of websites and being able to send information that described what your website should look like across a network. And your web browser knew how to take that information and turn it into pretty pictures and text. That's what a web browser does, right? If you ever go to a website and you right click, you go to like this website, I right click here and I say view page source. In here, or do I have to inspect first? Well, here, I'll just inspect. So over here is our this is what that page actually has in it over here on the right. There's a whole bunch of HTML stuff, which is HTML is it's a precursor to a competitor to JSON called XML. which is just a way of describing data. But in any case, this is what actually gets sent over the internet, this wall of text over here to the right. Your web browser takes that and turns it into something that looks more usable. All right. But the actual communication, the data itself, is being packaged up in HTML and then thrown across the internet. And it is the HTTP protocol that is used to request that stuff. So if you go to google.com from your web browser makes a GET request to google.com's web server, and the web server then responds with Google's homepage in HTML, which the browser then turns into pretty pictures and text for us. All right. So HTTP consists of 4 functions. Get, put, post, delete. The idea here would be that every single API can put its all of the endpoints, all the things the API knows how to do into one of those 4 categories. Do I want to get new information? Do I want to update existing information? That's what a put typically is. So this usually is get info, update existing info, save new info. What do you think delete means? Delete existing info. So everything we might want to do with a data source, with an API, the RESTful way of doing things says it fits into one of those 4 categories. So when you write your API, you're just going to create a bunch of functions. Every function does whatever the thing that you want to do there is. And then depending on whether it is sending data back to the user, you would probably put that function as a GET request. If you are receiving something from the user to store new things into the database, it would probably be a POST request, so on and so forth. All right. So what's the irony about this is that HTTP has literally been around since the day the internet was born. Literally. It's been tested for a while, right? Yet our popular modern APIs, things that every single modern application talks to. You know, when you have your apps on your phones, most of those apps are data aware. They have stuff they get from outside of your phone, right? They go over the internet and they get sports scores, weather, stock prices, whatever it is, video game updates, all sorts of things. They're getting that information from someplace else, and it's probably hitting a RESTful API somewhere on the internet using this old school protocol that is nothing fancy, but still works. So our modern way of doing APIs, which are used in almost every modern application, is done with something that's existed since the first day of the internet. And then they just put that little thing REST in front of it and makes it sound fancy. But that's all it is. All right. For those of you who've worked with APIs before, sometimes you might see something written like that. CRUD. CRUD effectively describes this. So D is delete, U is update, C is create. What does R stand for? Retrieve. I think it's retrieve, which effectively is these 4 things. It's boring, but this is what it's based on. All right. This is the underlying technology. We don't have to remember this ourselves unless we're writing our own APIs. And there's all sorts of tools out there for creating our own APIs. There's one called Fast API, which basically says, hey, I have some ideas for some functions. I want to wrap it inside of an API so I can connect to it from 5 different programs. All right. Whatever, something along those lines. So now let me introduce JSON here. So we have JSON, and I'm going to call this the upgrade to XML, which is, let's call it mostly a truth. It's a big enough truth for this lesson. You know, there was a time period where they were both kind of used interchangeably or whatever, but we've seen examples of HTML-esque or XML-esque stuff when we look at HTML. So if I look at a web page like this is HTML code, and everything has an opening tag and a closing tag associated with it. That's the premise that XML is based on. You have opening tags and closing tags that describe your data. So maybe you have a player, opening player tag, closing player tag. A player has a name, opening name tag, Mike, closing name tag. A player has an age, so on and so forth. So you mark up your actual data with a formatting approach to make sure that you can extract data with meaning, has some kind of semantics. Now, one of the weaknesses with XML, not that we necessarily care today because our internet's pretty fast and the amount of data we're typically serving from an API is not gigantic amounts of data. It could be, but it's typically not. Is when I look at all this text, obviously not diving into it, you know, there's a whole wall of this stuff here. It just produces this. So to keep it simple, we can say we're wasting a lot of space organizing our data instead of storing the data itself. All the data is there. We just are putting a lot of extra text around it to describe it to whoever's receiving it, in this case, the web browser. So one of the things, so we can say upgrade to XML. So we can say XML was very verbose with extra characters that, call it, bloated the data transfer. Potentially noticeable when you were on dial-up modems, probably not noticeable today. All right. Secondarily, XML did not support collections. So we couldn't have arrays of tags. If I had an open and closed player tag and I'm representing a team of players, in XML, I would have had to have I could have opening team, closing team, but then inside of there, I'd have opening player, closing player, opening player, closing player, opening player, closing player, not in something that is a collection that I could then process by walking through it with a loop. I would instead have to just keep parsing through the XML until I ran out of players. That was my getting the collection of stuff. Not really a problem. Everything was still doable. It just wasn't convenient. But
What's XML?
what it stands for, extensible markup language. So that's what it stands for. We can say looks like HTML. In fact, HTML can be written using XML. You've probably even seen some of your modern browsers might have a mode. It's usually off by default called XHTML mode. And XHTML mode says, here is HTML defined using XML, so it has to follow the actual structural rules of HTML. For a long time, including probably still some today, web browsers kind of were loosey-goosey with how they interpreted HTML, and they allowed for less than perfectly formed HTML to still work. That's why if you are a web developer, even today, when you write stuff, you have to test it in all the popular browsers to make sure it looks the way you want it to look for that browser. Because at some point in the history of that browser, it's very likely added a whole bunch of like one-off hacks to say, well, if they wrote stuff that looks like this, translate it as if it was this, that kind of stuff. So even though XML can be used to create HTML, HTML actually predated XML. HTML was the muse for XML. We saw this thing for describing web pages that was tag based. They said, hey, can't we make our own tags and describe other things other than web pages? Hence XML. It's not difficult, but it's very verbose. JSON's better. is the punchline. So XML did not support collections. So we can really just look at those two things and say XML had a lot of fluff and XML didn't have collections built in. So we kind of had to just make it work. But it did everything we needed to do. JSON's not bringing something to the table that was impossible to do with XML. It's just making it much more straightforward. So JSON, anybody know what JSON stands for? We stole JSON from a programming language. This is JavaScript object notation. What's an object? Collection of fields, constructors, and methods, right? So if I have a whole collection of objects, in order to create those things, we have the logic inside of the class, but the actual data associated with the object is the fields. So if we can store all those fields in name value pairs, that's JSON. So JavaScript uses this notation to store its objects. That's how objects are passed around in JavaScript. And it looks a lot like coding stuff. So if I go back here. Oh, here, this is what we got out of that cat fact thing. Let me just do this, then this. I'm going to make it look a lot better here in a second. No, this is what the cat thing spits back. So I'm going to write this formatted so it looks more like code. Something along those lines. So this is something called a JSON object. Opening and closing curly braces. We're pretty used to seeing curly braces. It's kind of a coding looking thing. And this guy has two name value pairs, two attributes. It has a fact and it has the length of that fact. And remember, this API was called cat facts. So every time I hit it, it gave me some special fact about cats. So the fact here is the most traveled cat is Hamlet, who escaped from his carrier while on a flight. He hid for 7 weeks behind a panel on the airplane. By the time he was discovered, he had traveled nearly 373,000 miles. And there's 217 characters in that. If I were to refresh that page, so this is that same page we were just on, I'm going to refresh it. Notice the text changed. This is giving me a new JSON object containing a new fact. All right. So this is a fairly simple JSON object where it's just opening curly brace, closing curly brace with a bunch of comma delimited name value pairs in it. So the syntax for JSON. So we have two different kinds of animals. We have a JSON object. A JSON object is opening curly brace, then name value, name value. That's the syntax for building JSON objects. It's comma separated name value pairs. So here I'm showing a potential of 3. So here's the first 2 followed by an infinite number. That's the dots. followed by a final last one that doesn't end with a comma. We see here that this JSON object follows that format, opening curly brace. Here's the name, here's the value. Here's the name, here's the value. Separated by a comma. All right, good.
So is that what JavaScript is like?
Well, this is what JSON, this is what a this is what an object being passed around your program in JavaScript looks like. JavaScript itself, the actual syntax, looks like everything you've seen so far. It's C++ based. So from your perspective, the only thing that would change is it's a loosely typed language. So you wouldn't say int a equals 5. You would just say a equals 5. Actually, JavaScript, you say var a equals 5. And then you're just telling it, you figure out that it was a number. Otherwise, it's the same language you're already used to. In fact, really, Python is among the languages that a less experienced programmer might find frustrating a little bit at first because you're so used to the curly brace world and Python doesn't use them. But Python does use, here, let me just jump over to my code here. I would actually say the best thing that Python does, I've lost my browser. Oh, there we go. The best thing that Python does is force indentation. So when we first learned to code, remember how much I've harped on the fact that make sure you indent your stuff. When you create a for loop, put your opening curly brace there, go ahead and put your closing curly brace right after it. So you created your little sandwich, then go put the meat in the middle. Believe me when I say I am a completely disorganized person in real life. So the fact that I am so picky about this from a programming perspective, probably should take it to heart. You've seen my tabs. Okay, I am not an organized person, but formatting your code is very important, especially for debugging. So if there's one thing Python does really, really well is it forces that issue. Here's a function in Python. How does Python know that all this stuff there belongs to that function? In Java or C++, we would have an opening and closing curly brace before and after it, or we could put it all on one line if we wanted to. Python doesn't support those opening and closing curly braces. So the way it detects that all these things are part of this guy is that they're indented at the same level under this. Similarly, how do we know that all that stuff is part of this try? How do we know that this one line is part of that catch? Or the exception catch. It's all because of where it's indented. So great. If that was all that was, if Python did everything else that the languages we've been using did, from a learning perspective, we would probably be using it. The reality is for the same reason I'm using Python as our example here, Python has a lot of very, very, very powerful tools just built into it. So you've lost out from a student perspective on the learning process of getting used to writing algorithms because it does so much for you. So I use Python all the time now because it just works for things I want to do. I don't need to practice for loops. Okay, but when you're a beginning programmer, you need to put in those reps so that you appreciate the autopilot for this guy. All right, so what are we doing here with Python? Well, we're saying here's the this is just a variable. I have a variable called URL. It's set equal to, in this case, just the string that is the website we're getting our API from. This is a super easy API. You get into more complex APIs, you might have to give it authentication keys and stuff like that. So we're keeping it as simple as possible. I'm using this package built into Python called requests that allows you to make HTTP requests. All right. So I'm going to go ahead and remember I mentioned back here that HTTP has 4 functions: get, put, post, delete. We're going to create a variable called response and set it equal to request dot get, call the get function on whatever that URL is. So what this line right here is doing is identical to me hitting refresh there. That is me making a get request to that website, because that's the requests that web browsers make when you use the URL thing at the top. It's always a get. Sometimes web forms do a post where things are somewhat hidden behind the scenes instead of pass through the URL, but that's a whole nother argument. But in any case, we could pretty quickly make the assumption that there's probably a request.post and a request.put and a request.delete that implements those 4 different functions of HTTP. All right, so I'm saying get whatever this URL replies with. So I'm catching my response. This is like an error checking thing. We could have deleted it and just assume we never have errors. Now I'm going to take that response that comes in as like an object, and I'm going to turn it into JSON. Then I'm going to print that JSON. So we saw that here on our web browser, when we make a GET request to that website, we see JSON. If I run this program, I make that GET request, we see JSON up here. That's the JSON. Oh, look, it's not very, they must only have a very small number of unique cat fags. So that's the JSON we receive from the site, but now we have it inside of our program so we can do stuff with it. All right, so what am I doing with it? Well, I'm going to, from that JSON, I'm going to get the fact. That is this attribute right here. That's going to store all that stuff right there inside of this variable called fact. Then I ask the question, is fact a thing? Does it have stuff in it? Is it not null? If it's a thing, go ahead and print out the fact. I'm just printing, here's cat fact. I'm labeling it as cat fact. That's that guy right there. Then I'm displaying whatever that fact was. If instead of getting the fact, I wanted to just print out the count, here's the other thing. What was it called? Length. I can say I no longer want fact. I want length now. And then I can say, well, we can still say if this will still work. I haven't labeled them real great, but now we see we just get the length portion of that. That 94 is what was associated with our length right here. All right. So JSON is a convenient format for passing around name value pairs. Now, so this is the syntax for a JSON object. We also, and this was that upgrade to XML, we have a thing called a JSON array. A JSON array is square brackets, just like we're used to for arrays of things, followed by comma delimited JSON objects. Like that. So if I wanted to build one of these real quick, I'm going to go ahead and I'm going to steal this JSON that came through there. I'm going to put a opening square bracket, closing square bracket, and then I'll go ahead and paste those facts in there. Let's run this again, get another one. I know I'm using these bullet point things here, but hopefully you get the fact, the thing here. We'll do one more. So there's an example of a JSON array. It is a collection, opening and closing square brackets, just like we're used to seeing arrays in the programming languages we've had, or lists in Python, which are arrays, implemented a little differently, but effectively they're arrays. And then inside here, it's a whole bunch of things that are JSON objects. Now, you could have another JSON array inside of a JSON array. You can have a collection which holds on to JSON objects which have collections in them. So this can get pretty complex pretty quickly. And JSON is a really good tool for being able to pass around formatted data that has, I guess, semantics to it. You're able to metadata is typically what we might call it in techno speak, but it has metadata that tells us what each thing actually is so that we can go through, process it, and do what we want with it. That makes some sense? All right, so hopefully what you see here is that hitting some external website, getting its response, and using that inside your program is not a major deal. We don't always have to be the inventors of our data sources, right? Usually we're writing the logic that takes something that already exists and puts it onto the screen in a usable form. So in this case, we've made our $1 million app of cat facts, right? We can spin this up into an iPhone app, talk to JSON with Swift, Apple's language, just have page after page of cat facts, sell it for $100. I'm sure we'd not sell any of them. Actually, you probably would sell one. Some idiot in the early days of iPhone, somebody created an app that was just called "I Am Rich." It was like $1,000 app that was just an icon. Yeah, Apple has changed some of their standards for those early apps. All right. Now, I am not going to be asking questions about JSON and XML on the exam. Obviously, this was just like a quick little crash course in it. But hopefully you see that you're coming to this point right now where you have all these basic programming skills. And those things now link to you having the entire world of external data available to you, lets you start bringing other data into your programs. Once you get it into your program, it's string manipulation. It's array manipulation. Go through every element of this array and do something with each value. It's the same stuff we've been doing, just your data got more interesting. Does that make some sense? The one I usually use is some Pokemon API that, you know, because students are into that crap. So, but I did this 5 minutes before I walked into class. So this is what we got. All right. Questions, comments, concerns, bribes. All right. So I'll see you when I see you. Make sure you do the exam next week sometime during the week. Hopefully I didn't stress you out too much during the semester, but I think I gave you a little bit of a reprieve the last week and a half or so you can kind of get ready with your other classes. Next semester, hopefully a lot of you are taking coding 3. So it should be a good class. I historically have taught it, but I taught the teacher who's teaching it. So Blade was my former student. He knows how to code. You might just have to work with foreign languages a little bit, but good guy, knows what he's doing. So you're in good hands, I think. All right, I will see everybody when I see you.
Question. It's not in the class.
Okay.
So